Okay, welcome back to 6.1 concepts of oxidation and reduction. In this video, we'd like to talk about oxidation and reduction can be defined in terms of combination with oxygen, transfer of electrons, or charge in oxidation number. Now, what I would like you to be able to do after this video is this first dot point. Identify oxidation and reduction in given equations. All right, so let's go to the slide where the reaction starts. Okay, so in redox reactions, what can happen is electrons can be transferred from one species to another. Their reduction and oxidation, they are opposite of each other, and both processes happen at the same time simultaneously. If something is being reduced, then another thing needs to be oxidized, and they happen together. That's why you combine and say it's a redox reaction. Now we will watch this video and we'll write down an example of it in the lesson. So leave some space on your book, please. All right. Now, these are the rules for you to identify what oxidation looks like. Now, I want you to leave some gap for example to go. I'm just going to go through the rules that you would use to recognize oxidation. Okay, oxidation reaction. Oxidation can be defined as a process in which, one, oxidation is added to reactant. You're oxidizing it, you're putting oxygen into it. Simple. 2, hydrogen is removed from a reactant. So that's an oxidation. 3, electrons are removed or lost from an atom, molecule, or ion. 4, the oxidation number of an atom is increased. Say 2 plus 2, 3 plus, or 2 minus 2, 0. So that's an oxidation. Now, it looks very similar on this slide, but this is for reduction. Reduction can be defined as a process in which, 1, oxygens are removed from a reactant, hydrogen is added to reactant, electrons are added to an atom, molecule, or ion, and 4, the oxidation number of an atom is decreased. So that's a reduction. You would notice that these rules for reductions are opposite of what happened to oxidation. Make sure you leave some gaps for examples that we'll go through in class, please. Now, mnemonic for oxidation and reduction in terms of electron, it goes like this: oil rig, oil rig. Oil rig stands for oxidation is loss of electrons and reduction is gain of electrons. So write down a mnemonic and you need to be able to use that. Now, these are the terms that I want also you to get familiar with. English is a quite unique language that you can put things into different grammatical sense, like passive form, or something is oxidizing or oxidized. What are they? They're actually oxidizer or oxidizing agent. That's another name for it. So yeah, when you have what's called oxidizing agent, which is also known as oxidizer or oxidant, yeah, what do? They oxidize the reducing agent, reducer, or reductant. Yeah. Reducing agent, reducer, or reductant, they reduce oxidizing agent, this way for you, oxidizing agent, oxidant, and yeah, oxidizer. What do oxidizing agents do? They allow oxidation to occur. It is reduced itself, and it gains electrons. So it gains electrons. It's reduced itself. Gain of electrons is a reduction. Yeah, gain of electrons. Sorry. On the other hand, this side, reducing agent, they allow the reduction to occur. It is oxidized itself and it loses electrons. Loss of electron is oxidation, wasn't it? Yeah, loss of electron is oxidation, oil rig. Last slide here. Consider the equation below. All right, you've got NO2 plus O2, that becomes NO2. I'm intentionally putting something that you would have seen in the acid rain part. What's being oxidized and what's being reduced? Let's see. Well, let's see what the oxidation numbers are in each atom at each state. So nitrogen, I'll point this out here. Nitrogen was bonded to oxygen in the reactant, and oxygen is -2. Therefore, nitrogen need to be +2. On this side, on the product side, there are 2 oxygens and they're both 2 negatives, -2. Therefore, nitrogen here needs to be +4 because there are 4 negative charges. 4 positive charge need to be applied to nitrogen, like so. So nitrogen changed from +2 to +4. If you look at this reactant, element oxygen gas, which should have 0 as its oxidation number, but now they're all bonded to nitrogen. Therefore, its oxidation number changed to -2. Oxygens want to gain electrons, which they did. 2 electrons per atom happened. Yeah. All right. So what's being oxidized and what's being reduced? Determine which element was oxidized and reduced. In this case, nitrogen was reduced because it lost electrons, 2 electrons. Or you can also say that oxidation number increased, whereas oxygen was reduced. Why? Because it gained electrons. Or its oxidation number decreased. Hope that makes sense. Now, which one was the oxidizer and which one was the reducer? Oxygen species, O2, was the oxidizer. And nitric oxide, NO, was the reducer. Now, it's not nitrogen only, it's not oxygen as in oxygen atom only. You have to give the species name. Maybe you should add that somewhere on the side as a note. If you're asked to state an oxidizer or reducer, or oxidizing agent or reducing agent, you need to give the name of the species or formula of the species. All right? That's the end of this video.